In this video, I want to review some concepts about the standard deviation and kind of talk about some transforms of data sets. All of it's pretty short, pretty quick. So, first of all, rank the following in order from smallest standard deviation to largest standard deviation. So we're going to put numbers next to the letters here. 1 will represent the smallest deviation, 4 will represent the largest deviation. Okay? Now, I don't want to do any kind of calculating here at all. I really just strictly want to go by what is the definition of standard deviation, or what does standard deviation measure. So standard deviation is a measurement of how things vary from the mean. So I'm going to write X bar. Okay? How do things vary from the mean? So I think you could look at these sets because they're pretty simple and say, boy, the mean in every one of these sets is going to be 3. Okay? In every one of these sets, X bar is 3. So then you say, well, which one has the smallest variability from 3? And I think you would look and say, well, in letter C here, only 2 values differ from the average. So that must have the smallest deviation. Okay, so I'm going to put a 1 there. That's the smallest. Next, let's think about which one has the largest deviation. It would probably be the one that the most values are different or further away. So it would be letter D. Now, between the last two, you see here we got 4 values that differ from the average, and in A we've got 6 values. So this B would be the second smallest, and then 3 goes here. So again, we didn't need to do any calculating. All we needed to think about was the definition of deviation. A data set has a mean of 12, a median of 16, and a standard deviation of 3. Okay, number 1, what is the shape of the distribution? Well, really, when we talk about shape with this kind of information, we really look at the mean and median. And we remember that the mean is not resistant to outliers. So if the mean is being pulled away from the median, it's probably by some set or some data that is, in this case, lower, because the mean is below the median. And the median, remember, is resistant to outliers. Some low data point is not going to pull the median, but it will pull the mean. So we would say that this thing is skewed left. Remember, skew describes, or the direction on skew describes the where kind of the tail is, or that outlier is. So if I could draw just a quick picture, maybe down here on the bottom, here would be something like, here's the median, right? And if there's an outlier, I'm guessing the mean is being pulled down to the outlier. So that would mean the mean is below. And really your reasoning here, how did we know, or how did I know, is that the mean, X bar, is below the median. So if the X bar was above the median, it would be skewed right. And if they're roughly the same, you'd say the distribution is symmetric. Okay? If every piece of data was doubled, find the mean, median, and standard deviation. Well, if I could real quick, let me make a simple data set. Okay, I'm going to make this for number 2. So my simple data set that has a mean of 12, median of 16, and standard deviation of 3. I'm going to just make a random data set. Random data set that I used the other day in a video. And that data set is 3, 5, and 7. Okay? If every piece of data was doubled, okay, so let's double every piece of data. We got 6, we got 10, and we got 14. Now you ask yourself, what has happened to the mean, median, and standard deviation, or variability? Well, you'll notice that the mean was 5, now it's doubled to 10. The median was 5, now it's doubled to 10. The variability in here used to be 2 from the mean, and now it's 4. So if every piece of data is doubled, every measurement got doubled as well. So going back to the data set they actually gave us, the new mean is 24. Okay, I'm going to write that just next to it, 24. The new median would double to be 32. and the deviation would double to be 6. Okay? Now, let me make another note here for number 3. It says if 6 was added to each piece of data. So I'm going to go back to the original 357. I'm going to add 6 to every piece of data. 9, 11, and 13. So compared to the original, you see the mean was 5. Now it's 6 more than that. The median was 5. Now it's 6 more than that. The spread in the data was 2. It's still 2. So if 6 was added to every piece of data, the mean, well, for our original data set, the mean went up by 6 units, so it's 18. The median will go up by 6 units, so it's 22. But the standard deviation would not change at all. Okay, so again, I know I didn't use the original data set. I wanted to use a very simple set to illustrate these rules. And if you ever forget them, I would urge you just make a quick little data set and do the transforms, and I think you'll see it right away, the things that have been adjusted, the things that are being translated along with the data. So just as kind of an overarching idea here on adjustments to data, let me just talk about this. If outliers are taken out or outliers are put in, the measurements that are affected or most affected, the mean and the deviation. Okay, I'm also going to write SX here because, of course, in this class we usually use the sample deviation almost entirely. We don't really use the standard deviation because that presupposes we've been given information about the whole population. So those things are affected greatly by outliers, and we talked about that in a previous video. So if a number is added or subtracted from a data set, what measures are affected? Well, what we just saw is that the mean and the median are going to change in that case, right? They're going to be shifted up or down. And I sometimes like to think about this almost in terms of like a simple like box plot or something. And I think if you add or subtract and you shift this thing up, you just say, okay, I'm shifting the entire box up to maybe, if I draw another one, something like this. It's the same exact box, just shifted. You haven't changed the variability or spread of the data at all. It's still going to be the same width. But as you saw in the previous example, if you multiply or divide, what measures are affected? Well, in this case, still the mean and median, but the deviation and also the measure of variability based on the median would be as well, the IQR. Those will all be affected by multiplying or dividing. And again, if you ever forget that, make yourself a three number data set and check.